Hello guys, welcome to Pepcoding, and now we are going to discuss the next question, that is binary search tree iterator 2. Okay, so in this question what we have to do is we have to create the iterator of the binary search tree of the BST tree. Okay, binary search tree. So we have to create the iterator. And what is the iterator? Iterator is like one by one we iterate the tree. Okay, this is the another form of traversal. Okay, suppose this is our tree 30, 20, and this is 50, and this is suppose 10, this is 25, and this is 50, not 50, this is 45, this is 55. Okay, and we want to create the iterator. Okay, so what we will do is if we call this next function in this question, we have to like figure out these two functions. So if we call the next function, so it is going to print the 10 because we are going to traverse this tree in order. So first if you call this next function, so we are going to get this 10, then we are going to get 20, then 25, then 30, then 45, then 50, then 55. So this is how we have to do this. Okay, so we have to iterate the binary search tree, BST tree. Okay, in the form of in order traversal, and we have to do the in order traversal. Okay, so we have to design these two methods, that is next and has next. Has next is actually a method which return the true or false value. Okay, if there is value present, if the next value is present in the tree, then it will return the true, and or else it will return the false. If there is no node present in the tree, then it is going to return the false. And what is the next return? Next return the next value in that binary search tree, BST tree. Okay, so let's see how can we do this. So let's we go. So this is the tree and this is what we want to achieve. Okay, so now the tree is given, so now we have to achieve the iterator. Okay, so like next, we can get these values. Like if we do one time next, then we get 7, then 15, then 17, then 22, then 27. So as this is an in order traversal, so in order traversal, the items are in ascending order. All the elements are in ascending order. So let's see how we iterate the in order traversal. Okay, so when you are started with the root node and when you go to the left part, so what we have to do, we have to move to the leftmost part. Okay, so first we go to the left, again to the left, possible left, and when there is an end, then what we do, we just print the number. So we printed 7. Then if the number are not present to the left, we are to the leftmost, then we visit to the right of left. What is the meaning of right of left? We will see it further. Okay, so there are no element in rightmost also. Okay, so then what we do, we just backtrack, we go to the back last element, then we go to the 15, and then we just visit to the next path. And what is the next path? The next path is right of left. Okay, so right of leftmost. I will write all the steps. Okay, so don't get confused. Then what I will do, then I go to the backtrack, then I am going to print this number. In each backtracking, what we have to do, we have to print the number. Then again I will explore the right of left, so I explore the right of left. Okay, suppose let me add some more values, that is 16, or you can say 15 or 40. So what is going to happen? So we have to explore the right of left, so we are going to move in this path. Okay, then we are going to print this number. Okay, so like this we are going to iterate it, like this we are going to print this. Okay, so let me do this actual. Okay, so this is the thing. So now what I am going to do, I am going to explore the right of leftmost part, then we get 17, then I am going to print 17, then I again traverse the right of left, but there is no right of left. So then what I just do, I just backtrack and then again print, then again print. Then what I will do, then again I travel to the right of left. So what is the right of left? There is no left. Suppose there are left, suppose there is 26, then I move to the 27 and 26. Okay, then print 26, then print 27. Okay, but there is no 26. So where I move to the 27. Okay, so this is how I am traversing. This is how we traverse. Okay, then what we do? Then we simply jump to the 30, or you can say here and here, but we have explored all the path. We have explored already. Okay, then we jump back and back. Now, again, now we have to go to the right of left. Okay, so each time what I am doing is, see, let me do all print Z. So in the end, I would like to brief myself. So what I am doing is, first I am moving to the leftmost part. First I am moving to the leftmost part. Then what I am doing is, I am moving toward the right of leftmost part. See, right of the leftmost part. Okay, so this is the path which I am doing. And if we are getting both null, right and left both null, then I am going to backtrack and then explore the right of left. So this is the path which we are going to do. Okay, so let me just simply tell you in the form of solution, like how we are going to solve this. So in this, we are going to take the help of the stack. Okay, so in this question, what we are going to do is, I am going to take the help of the stack. So let me create one stack. So this is our stack. Okay, so this is our current stack. Now let's traverse it. Okay, so first for what I will do is, I'm going to go to the left. So I'm starting with this point. So I'm going to, when I'm traveling, I'm going to insert each and every element. Okay, so first I'm going to push 30 in the stack. Then again I move to the 15. Then again I'm going to push 15. Then I am going to move 7 here. Then I'm going to push 7. And now there is no element in the left side. So if there is no element to the left side, then what I'm going to do? Then I'm going to pop the element and print it. So these two operations are going to do one by one, pop and print. Okay, when the element will pop, it is going to print. Okay, so what I will do, I'm going to pop this element, print this element, and go explore the right of left. Okay, then what I'm going to do, I'm going to explore the right of left, but there is no right of left. There is no right. So what I will do, I'm going to backtrack, and when I will backtrack, that means we have to print. So let me write it now. So first I'm going to leftmost part. Then when I was in the leftmost part, then I'm going to print it. Then I'm going to print this. And then what I will do, I'm going to visit the right of left. Then I'm going to explore these path, right of left. Okay, right of left, that is this path. I will go move to a right. Then I am going to insert this element to the stack. Then again move to the left. Then again left, and then again left. And these all element I will insert into the stack. Okay, so in the end you will connect all these dots. Okay, so again I'm going to repeat this same thing. First I'm moving toward the leftmost part. If leftmost is null, so I'm going to print it, and then I am going to explore the right of left. Suppose this is also null. Suppose this is also null. Then what I'm going to do is, I'm going to backtrack, then print, then again the same thing. Okay, then again the same thing. Backtrack again to the leftmost part. If left is not present, then right of leftmost part, and then again backtrack, print. When I will print, then I will pop from the stack. If I will print, I will pop from the stack. These two things are like both are going to happen continuously. Okay, if I'm going to print, I'm going to pop it. So now let's implement this, and in the end you will able to understand what I'm going to say. Okay, so let me create this path. So first I'm going to left, I'm going to print this, and then I'm going to explore the right of left, but they are not present, so I'm backtracking. Then when I will backtrack, I have already told you that when I will backtrack, I'm going to pop the element, print the element, print the element, and explore the right of left, that is right of left is this path. First I'm going to go here. When you will go here, then 22 is going to insert in the stack, then right of left, then I'm going to move here, then 17 is going to insert here. Okay, then 17 is going to, suppose there is some more elements, so all the element will be inserted in the stack. Okay, so now we are in the leftmost part. Then again the same thing is going to happen, that is we will pop the element. Let me change the color. We are going to pop the element, print the element, and explore the rightmost of left, but there is not present. So what we are going to do, we are going to backtrack it. So when we will backtrack, we are going to print it. So when we are going to backtrack, the topmost is the top element, the backtracking element, we are getting the top of the stack. Okay, that's why we are popping it. Okay, 22 is the last element. So what we are going to do, we are popping it. Okay, so we are popping this. I will pop this, print this, and explore the right of left, but left is not present, so I'm going to insert this only. So 27 is going to insert here. Okay, then again there is no element present. So first what I will do, I'm going to pop this element, print this element, and then explore and then backtrack. And how we are going to backtrack? In the form of a stack. So when we will backtrack, we will find the 30 is there. Okay, so we directly jump toward the 30. Then again in backtracking, what we are going to do, we are going to print it, and then we explore the right of left. The same thing is going to happen. Okay, so this is our algo part. So let's go and code this. Okay, so now I'm going to code this in C++. So let me do the full screen. Okay, so how we are going to do, we have to complete the next method and the has next method. Okay, so how can we do this? So actually what I'm going to do is, see, I'm going to create one more method, that is all left. And what this method will do, I'm going to fill all the left in the stack. So this method is going to fill all the left node to the stack. Just see, I'm going to pass some node. Okay, so in starting I'm going to pass root, so it will fill 30, 15, 17. Okay, then what I will pass 22, then it is going to fill 22 and 17. Then again I will pass 60, then it is going to fill 60, 45. So like this I am going to take the help of this method, and then I will create the next method. Okay, so I also have to take one stack. So let me create one stack, and what is the type of that stack? Tree node. So I'm going to insert the nodes. Okay, and what is the name? Stack name is st. Okay, so I have created the stack, and now what I'm doing is I'm going to call the all left method. BST iterator is going to just insert all the element in the stack. Okay, BST iterator is doing like this. So that's why when we put all the element to the left, then we will get the next element. Okay, so what I'm going to pass here, I'm going to pass here root. Okay, so it is going to insert all the element of the root. Okay, then what I will do, let me create one method, public static, no, let me take only void all left free node star node. Okay, this is our method, and then what I'm going to do, I'm going to use the while loop. Okay, so when node is not equal to null, then what we have to do, we have to insert the value. See, like this. So first I'm going to pass this, so it will we are going to insert this node to the stack, then we are going to insert this node to the stack, then we are going to insert this node to the stack, and when it is null, then what I will do, I will call it, I will terminate it. Okay, so when node is equal to null, then I'm going to terminate it, and each time I'm going to change the node is equal to the node dot left. So let's see the code here, and I'll all left while when node is not equal to null ptr. Okay, when node is not equal to null, then we are going to push the node in stack. Okay, so then I'm going to push the node in stack, and then node is equal to, we have to change the node, so node is equal to node dot left. So by this I'm going to store all the left nodes. Okay, then what I will do in next, so next element is going to return the next element. Okay, and where is the next element is there? Next element is the top of the stack. Okay, this we already know. So before writing this method, let me write the has next. So when we will know, like we are having some method, we are having some nodes in the binary tree. How we can see that? So if our stack is not empty, that means if we are having some nodes, if the in the end the stack is going to empty. Okay, so if our stack is not empty, return st dot size is not equal to 0. That means we are having some node in the binary search tree, in our binary search tree. Okay, so now in this we have to design the next function. So how we are going to design the next function? So for this, what I'm going to do is, the topmost element is the next element. So I'm going to store the topmost element, tree node, and then I just simply do the node is equal to, what I will do, st dot top. This is our topmost element in the stack. So this we already know. When we have pushed this, see here, when we have pushed this was our topmost element. But when we remove this, when we pop this, what is going to happen? We have to insert all the element to the right of left. Okay, so rightmost of left, we have to insert all the nodes for it. Okay, see in this example, so what we have done, we have inserted all the element of these. So after popping this, we have to do something more. So st dot pop, we have popped it. After popping, what we have to do, we have to insert the node of the left part. Okay, so what I will call this method all left, which is going to insert all the nodes of the left part, and now I'm going to pass node of right. Okay, so it is going to fill all the left element of the right node. Okay, again I'm repeating it, it is going to insert all the nodes in the stack of the right node of the left element. Okay, so it is going to store all the leftmost element of the right node. Okay, so I have called this, and then in the end what I'm going to do is I'm going to return the node of well. I'm going to return the node of. So let me run this and check for the compile time error. So it is accepted. So let me submit this. and yeah, all the test cases are running fine. So thank you guys for watching this video, and we'll meet you in the next video.